Sam with Nexus Workshop, and we are here talking through all the different configuration pages of the prop controller. The next one we're going to talk about is this definitions page. The definitions page is where I make sort of the building blocks that are going to be used throughout the rest of my thing. So I've already connected up all of my inputs and my external systems, and I've defined the behavior of my controller. Now I need to define a couple things about it. The first one is states. States are something that the controller is in. There's only one state at any given point in time. I have any number of states I can have, but I can only be in one. With that, it's the simplest way to do things like, again, most of my props tend to have a off, an armed, and a solved, where they have a different behavior in each. Armed being the one where it lets them do the thing, off kind of does nothing, and solved, they've already done it, it's sitting there in a way. You don't have to use states at all. You could have no states. But there are also other things where you're going to get a little more complex than what states can do, and you're going to start to do the next thing, variables. With states, I add them here, and this is where, again, I'll say it for this video, but you're going to see this common sort of nomenclature of this plus state means add a state. This means copy this state and make another duplicate of it. This means delete that state. You're going to see that throughout our interface. Of these states, I'm able to give them each a name, and then I can choose if they are the action default. If I check that, it means that when we get to the actions later, that they will by default be available within this state. And I could turn that off, but if I, in general, have this sort of setup, I have an off, an armed, and a solved, then I want most things to work in the armed state. So I just check that, now they're all default there. I can also do this auto too. This is a transition. So solved automatically goes back to armed after 5,000 milliseconds, 5 seconds. So after 5 seconds, once solved enters, it automatically goes back to armed. That's a behavior that I can build in here without having to do anything else, without having to have other timers going. I just, yep, when this happens, that happens. Variables. Like I said, you can only have one state. So if I were to have things, I need to track multiple different things, I don't just need to say, hey, am I armed? I need to say, am I armed, and is this true, and is this, have they solved that other puzzle or done this other thing? That's where I might use it with a variable. I can add variables, and I can give them a name. I can reorder them within the list. That matters for the operator page only. It's just an aesthetic thing. I can choose their type, so I can make them either a string, that's text, typing, a number, that's a number, and Boolean, true or false, yes or no. And then I can give a startup value. That startup value is going to be what is it when the system boots. Otherwise, it's going to start null. It's going to be blank. Which, if that matters to me, I can put a starter value here. It's also possible that I don't do one, and I'm just always waiting for it to kind of immediately get written by something. Debounce defaults. This is a concept within electronics, with Arduino especially. You have a concept called debounce. When I have a button, it's possible for electrical noise to make that button look like it's moving. It's also possible for that to happen as it's going. Buttons are really susceptible to this. Analog values and things like that are constantly fluctuating are really susceptible to this. It basically says, a debounce is how long does it have to wait before I decide, yes, that actually got pushed. It is good practice to have debounce on all your buttons. That is one of the things that we make really easy that is a little bit harder if you're having to code it yourself, and one of the functions that you find yourself constantly redoing. Me, I'm going to always come in here, I'm going to go my digital inputs, I'm going to put a debounce of 40 on them. 40 milliseconds, that's pretty fast. But it says like, hey, make it push at least this long. In a really noisy electrical environment, I've done things where I've said, no, that button has to be pushed for like half a second, 500 milliseconds before it actually says, yes, I've been pushed. But that's just going to give you a little bit more reliability. You're going to do that at the sacrifice of speed. If I have to wait a whole half second after they push the button before it reacts, it's possible to not register a quick push. It's possible for it not to do things. So be careful with it. Don't go crazy. But 40 milliseconds is fast. It's not going to cause issues. Also, if you're doing something like reading a read switch or an RFID tag, has the thing put in that location. Doing it with a little bit longer of a lead time slows you down a bit, but that debounce is going to make sure that it really did land there, not that they swiped a magnet over it accidentally, that sort of thing. These debounce defaults can be overridden for individual things later, but doing them here is going to allow it to globally apply to everything as the default if you don't go and click. Input gestures. This is things like, with buttons, it's things like, what is a short press? what's a double tap, what's a long press, and what is a hold. I can create multiple input gestures, so I could take different buttons and give them different behaviors, or have complete sets of buttons that have different behaviors. And that's by doing it here. So like I have one button in here called the solve button. Instead, what I've done here is you always have this option called all others, which basically says, hey, if you don't have a specific setting that says you should be that, then you can be this, just as the default. Here I'm specifying out how long do they have to hold it before it decides, yes, it's a press. How quickly do they have to press it twice for it to be a double tap? How long do they have to hold it where it becomes a long press? And at what point does it become press and hold? Those gestures are events that can be called up later in other actions. Level inputs. Buttons are nice and easy. Yes, no, push, not. Levels, audio, analog things, have a lot of different behaviors. So like here I have, the idea is that I have a potentiometer hooked up, right? I've got a knob or a fader or a flex sensor or whatnot. I hooked up something that's reading analog. It can read between 0 and X. 4096 is what this one can read. So right now it's floating because I didn't actually hook it up. And so you can see this current value where it's kind of flying mostly all over the place, but right in the 300s. And there I can give it my name, of course, and I can decide which input is on. So this is me actually, analog level is the name of this type of input. And then this is the physical input that it's connected to. It's an input that I made called puzzle knob. I have a couple modes. I can go and do range mode, center mode, or map mode. Range mode would be if I were to say, let's say I have a fader, and I say from here to here is position 1, from here to here is position 2, from here to here is position 3. Center is the same sort of thing, but instead of specifying the top and the bottom, the min and the max, I can specify the middle of it and say, yep, from here and X far is this. And then I have the scale. There are different types of analog devices that have different scales, whether it be a linear scale or a logarithmic scale. What you're going to see this do when you have like a potentiometer, for instance, a little knob, on a linear scale, it's going to go from 0 to 4,000. Nice, easy. On a logarithmic scale, it's going to very quickly go on one side of that range compared to the other. And so it has to do with how that slope goes, and getting this right is going to be important. You can just kind of experiment with it sometimes to see, like, yeah, what makes sense. You have some other settings in here about whether there's a noise floor or it's adaptive. For things like a microphone or something like that, those would matter. And that's, I think, the most common place for noise floor to be considered is where there's electrical noise. There's some kind of noise in your signal, and you're looking for, hey, my signal needs, and this is what the trigger is about, is I need my signal to be, boom, it actually got pushed. I said, yes, you're loud enough for me to register a spike. That noise floor, if you make it adaptive, will automatically go. Another example of this is the little current sensor modules that can be used. We do those little current sensor modules. They have a big noise floor of like, what's going on down here at the bottom? And you need to say like, hey, where have I gotten out of that to say, yes, that was a hit. Turning on a noise floor so it's filtering out the bottom of it, and then turning on adaptive so that it's automatically choosing where is that bottom. It's going to be how you get there. Your threshold and your smoothing are going to be about that acceptability of how far you can kind of go in and out. On here, because I've got this pot, I've only created one at the moment, but I said, hey, there's a slot on here called floating. And you saw that back on the operator page when I showed that it said in parentheses floating, because I had named a slot here. I said, this is what floating means. And I did this learn center button. So I said, great. I put it to floating, but didn't touch it. And I hit center. And now it grabbed that and said, that's the center. If I were to have, like, again, a fader or a color sensor, I could put something in front of it, learn that. Or if I'm doing my fader and I'm doing a range, I could go to the very bottom of, yeah, I consider this that letter, that slot, that mark on the fader. That's the min. This is the max. That's the min. This is the max. And I can learn each of those as I go across. So I don't have to know what they are or type them in. I just click learn as I go along. I can add more slots. I can add more level inputs. And I would end up making one of these for each of my controls, each of my knobs. RFID learn and write, I'm going to do a video on a bit later once we have a little bit more of it fully locked in. But this is where I would define blocks within my RFID tags and how they behave. So one of the ways that I like to use RFID is not actually using its UID, but actually writing onto a block of it. It has storage on board that tag that you can write to. And so I like to write into it. Block 8 is one I always go for. I write into block 8 and I just write a number, or I write text, or I write something into it. And that's what I actually reference later on. The reason I do that is now I don't have to learn this tag. I actually set up this tag to be what I want it to be. I make the tag what I want. That means that I can make duplicates. I can have spares sitting on the shelf that are all programmed to be the same thing. Or when I lose one or one dies, I can just grab one, put it over my tag writer, say, great, you are now number, you're fuse 5. And now I can go put it into the game. That is where you're going to do that learn and write. And again, I'll show you more of that in another video. Audio files is if I have a sound module hooked up, it's going to look and pull the number of files off of there and allow me to give them friendly names. Those friendly names I can then use in the rest of my program, so I can be in an output sequence. Instead of having to say play track 7, I can say play the wind track or play lightning. And then I have this test button right here to make sure that it is behaving to the one I expect. That's the definitions page. Right up next, we're going to be going into behavior.